Solutions for Math 112. Given this kind of word problem, although it's not really a word problem since you're given the picture of the triangle, and basically you're told to determine h. Here's a triangle, figure out h. If you want to think about h as the height of a hill and this the angle of elevation, fine. Figure out h. So to figure it out, what you want to recognize is that the two angles, or the one angle that you're given, I guess, is this 37 degrees. And then you also know that you have a right triangle here. So you could figure out this angle if you need it, but you won't even need it because relative to this angle, the two sides that are either being asked or given are the side opposite and the side adjacent. So the trig function that relates together the opposite side and the adjacent side is our tangent function. So I can say that the tangent of 37 degrees must be equal to the side opposite h divided by the side adjacent, the length of those, which is 150 meters if you care about units. So to determine h, just multiply both sides by 150, and that's it. I mean, if you felt like it, you could try to ballpark what the tangent of 37 degrees is. You could calculate it, or you could get a decimal approximation if you had a calculator. But with no calculator, just call that the answer right there. 150 times whatever the tangent of 37 degrees is. Okay, next question says determine the distance from A to C. What's the hypotenuse? Well, a lot of different ways you could do that. One option, maybe option one, would be to note that I'm given the side adjacent this angle, and I want to know about the hypotenuse. So the cosine will relate together those two sides. The cosine of 37 degrees must be equal to the length of the side adjacent that angle, 150 meters, divided by the hypotenuse, which guess I have to label it. Maybe I call it x. So you want to solve for x? We'll multiply both sides by x and then divide both sides by the cosine of 37 degrees. And this will work out perfectly fine as an answer. Other ways you could solve this, you could realize that if this is 37 degrees, this must be, 53 degrees? And the trig function that relates together the side opposite this 53 degree angle and the hypotenuse would be the sine. So sine of 57. Anyways, other ways you could do this. Since I wrote option one, I want to write another option. So I'm going to go ahead and say option two. You could use the Pythagorean theorem. A, 150 squared, plus B, the height, which I figured out here to be 150 tangent of 37 degrees squared, must be equal to x squared. So x is equal to the square root of this stuff, 150 squared plus 150 tangent of 37 degrees squared. Either of those perfectly acceptable. Other answers also, might even note that other answers are possible. That's true both up here and down here. But I think that's everything I want to say for this one. So I'll move on to the second page. This problem, I think this one's a little bit harder. This I had in mind 6.2 in our book, where we're dealing with right triangles. And this one where you're dealing with other triangles that aren't necessarily right triangles. So I have this big triangle right here. This is 30 degrees, this is 40 degrees, and this is 50 right here. And you're asked to find this length. Well, if you don't think about the big triangle and instead make this two different right triangles, then we'll be able to figure out this length. This length right here, I don't know, maybe I'll call it y. And I'll call this y because I think I put a little hint on here, said call the distance from one of the guys to the point on the beach closest to the island x. In other words, this distance right here is x. And the reason I want to give that a name x is because I know 50 is the distance between the two people. So if this is x, kind of the rest of it, 50 take away that x, would be the distance from the other guy to this point right here. And by breaking that up, instead of knowing the length of this side is 50, you know the length of each of these two sides. I've changed a problem that deals with a non-right triangle into a problem that deals with two right triangles. And I can deal with two right triangles using SOHCAHTOA stuff. So what I want to do is relate together this side, y, that I'm trying to figure out, and this side right here, x. And I can do that because I know that this angle is 30 degrees, y is opposite, x is adjacent, so the tangent of 30 degrees must be equal to y over x. And using the other right triangle, I can say that the tangent of 40 degrees must be equal to, opposite this angle is again y, but adjacent to this angle is not x, it's 50 minus x. So I get these two equations. Y is what I want to figure out. So I will solve one of these equations for x and substitute it into the other one. So if tangent of 30 equals y over x, then x is equal to y divided by the tangent of 30. And I recognize that tangent of 30 is something that you know off your unit circle, and if you feel like plugging in that value now, you can. I'm not going to, but you could. If x equals this, I could plug in right here for x, or I could, that might get algebraically messy to have these fractions inside fractions. So I think when I demonstrated this problem in class, or a similar problem anyways, I first multiplied both sides by 50 minus x, and then substituted in. I said that the tangent of 40 degrees times 50 minus, and then instead of writing x, I know that x equals y over tangent of 30. So I can put that here. Equal to y. So I just substituted in. Instead of x, I wrote what x is equal to from over here. And now I want to solve for y. That's hard to do because I got two different y's floating around. However, I have a method for that. I get all the terms with the y in them on one side of an equation and I factor. But in order to do that, I got to get rid of these parentheses. So let's distribute this tangent of 40 through. So I got 50 tangent of 40 degrees minus tangent of 40 degrees divided by the tangent of 30 degrees times y is equal to y. So I took this tangent of 40 and distributed it through. That gives me this. Now I'm going to collect all the terms with a y in them on one side of the equation. In other words, I'm going to add this term over here to get y plus this tangent of 40 degrees over tangent of 30 degrees y. So add this term over here. And now factor out a y from each of these terms. Pull out the y, you got 1 plus tangent of 40 degrees divided by the tangent of 30 degrees is equal to 50 times the tangent of 40 degrees. So finally, to get the y all by itself, how about I'll do it on the other side. Divide by all this stuff. So 50 tangent of 40 degrees divided by 1 plus the tangent of 40 degrees divided by the tangent of 30 degrees equals y. This is a perfectly fine answer right here. You can leave it just like that. Maybe I'll put a box around this to indicate that I'm perfectly good with this answer right here. However, you can simplify this. You can write this in other ways if you want. Let's see. One thing I know is that the tangent of 30 degrees is 1 over root 3. So this is 50 tangent of 40 degrees divided by 1 plus the tangent of 40 degrees divided by 1 over the square root of 3. And that's because the tangent of 30 degrees is the sine of 30 degrees over the cosine of 30 degrees, and the sine of 30 degrees is 1/2, and the cosine of 30 degrees is root 3 over 2, and if you simplify that whole thing, you get 1 over root 3. But tangent of 40 degrees divided by 1 over root 3 is the same as 1 plus root 3 tangent of 40. So any of these answers are all equivalent, and there's actually lots of different answers you could have. If you move the y's to the other side of the equation, maybe this is negative and both of these on the bottom are negative. If you set this up differently, if you called this 50 minus x and this x, your answers might look a little bit different, but they're actually the exact same. The answer asked you to determine the shortest distance from the beach to the island, labeled with a question mark in the image below. With this question mark, I called that y, and down here I solved for y. It's a perfectly good answer, so I'll call this good and stop this video here.